Okay, let's talk about slant asymptote. Okay, I'm going to move this out, and let's talk about slant asymptote. Slant asymptote. And this kind of asymptote can look like this. Suppose I have a graph here, and I can have and the slant asymptote can be a broken line drawn like this. The slant asymptote is a line, an oblique line. And you can also have a vertical asymptote. This function, this unnamed function, can have a vertical asymptote. It can have a slant asymptote. Okay. So when do we have a slant asymptote? I'm going to write a question. So let me just write, make up a question. I'm making it up so that we can look at an actual question. X squared plus 1 divided by x minus 1. I wanted to see this function. We haven't had a situation when the degree of the numerator is greater than the degree of the denominator. So whenever the degree of numerator is greater than the degree of denominator by 1, there is a slant asymptote. Whenever, I'm going to hammer it down. I don't care if I'm shouting. I just want to make sure that maybe in 4 years you're still going to remember, oh, she shouted, because I don't shout. If you don't shout and you shout one time, people say, what's wrong with this guy? This is going crazy. You see, it's going to be one time when the degree of numerator is greater than the degree of the denominator by 1. That's a slant asymptote, and you have to find it. You got to find it by division. And then how do I find it by division? You already know how to divide. I already know. See, if I eyeball the function, I already know there's a slant asymptote. Why? Because see, even if just knowing that is even enough for some professors. They just know that that is important. Oh, okay, the function has a slant asymptote. Because why? Because the degree of numerator is greater than degree of denominator by 1. Okay, so what happens? Suppose I have x cubed plus 1 over x minus 1. Does it have a slant asymptote? No, because the degree is greater by 2. No asymptote. No slant asymptote. No slant asymptote. The only time you have a slant asymptote is when the degree is greater by 1. When it is greater by 2, 3, 4, 20, that's not a slant asymptote. So you can eyeball a rational function and describe it. You can eyeball. First of all, you already know that this function has a vertical asymptote, right? And if a function has a slant asymptote, it doesn't have a horizontal asymptote. If a function has a slant asymptote, it don't have a horizontal asymptote. Does this have a horizontal asymptote? What? Why? Why do you say that the horizontal asymptote is y equal to 0? Because the degree of the numerator is less than the degree of the denominator by 1, or the other way around, degree of denominator is greater by 1. So there is a horizontal asymptote, and the horizontal asymptote is y equal to 0. So HA is present, and it is 1, and y equal to 0. Does it have a vertical asymptote? VA Does it have a vertical asymptote or 2? Yes. So you want to write 9x divided by, equate the denominator to 0. So you have x minus 6x plus 6. That's the difference of two squares equal to 0, right? Factors are plus or minus 6. And so the vertical asymptotes are minus 6 and plus 6. So there are two vertical asymptotes. So vertical asymptote is present. All right. If it has a horizontal asymptote, does it have a slant asymptote? No. So you have answered the question.